Okay, hi guys. So in this lecture, we'll be looking at addition reaction of alkene. So let's start off. Addition reaction of alkenes. Okay. Now, if we have something like this, and we are reacting it in the presence of HBr and CCl4, then actually this is the partial positive charge and this is a partial negative charge. So the alkene would actually give its pi bond to attract the hydrogen ion here, and as a result this would have a positive charge, this would have CS3, and then this Br will actually attack on the carbocation to form this. So this would be the end product. So displacement of pi electron under the influence of electrophile will actually cause the bond to break, and for intermediate formation of carbocation will take place, and then the nucleophile will again attack on this, becoming the electrophile. So hence the complete product would form something like this. So what is the electromeric shift? Electromeric shift. So this is nothing but the displacement of pi electrons. Displacement of pi electrons under the influence of electrophile and nucleophile. Okay, so let us look into some more examples of the same. If we have this and it reacts with Hi, then this bond would actually break to attract H, and it would have a negative it will have product carbocation formation in the intermediate, and then I minus will attack on this carbocation to form this product. Okay, so this is an example of electrophilic addition. Okay, so let us take another example. Here we have presence of CCl4. So as you know that the positive charge, if the double bonds attacks, the pi electrons attacks on this H plus, the positive charge can either come on this carbon atom or this carbocation. So or this carbon atom. So we can either have something like this or something like this. So now obviously this is more stable than the below one. Why? Because it has more number of alpha hydrogen, hence this would be the major product formed, and then the Br minus would actually attack on this to form the major product, as this would be our major product and this would be minor product major. Okay, so I hope you have understood the electrophilic addition reaction of alkenes. Now we will start off with Markonikow rule. The Vladimir Markonikow okay, so Starting the statements. Statement 1 is, according to Markonikow rule, electrophile attack that double bond carbon which has more hydrogen atom. Okay, so according to Markonikow, electrophile attacks on that carbon atom which has more hydrogen atoms. Okay, and statement 2 is, um, rich becomes richer in terms of number of hydrogen atoms. Rich becomes richer of number of hydrogen atoms. Okay, statement 3 is, according to means some of the reference books, nucleophile attacks that double bonded carbon which has less number of hydrogen atom. Okay, so nucleophile attacks that double bonded carbon atom which has less number of hydrogen atoms. So all these statements actually focuses on just the stability of the intermediate carbocation which is formed as a result of attacks of either electrophile or nucleophile. Okay, so we conclude it with the modern statement which is, electrophile attacks that double bonded carbon which forms stable cation or stable intermediary cation. Okay, so let's write it like this. Electrophile attacks that double bonded carbon which forms more stable intermediary cation which forms more stable intermediary carbocation. Let me rewrite it. Intermediary carbocation. Okay, so this was about Markonikow rule, and let's take a look on anti-Markonikow rule. So we'll have anti-Markonikow rule as, so this rule is also known as peroxide effect, or okay, so this rule is just opposite to the Markonikow rule as the name itself suggests, and it's the product form is just the position isomer of what is the product form in Markonikow rule. Okay, so just writing it informally that just opposite of the Markonikow rule. Okay, and this reaction actually takes place in presence of peroxide Okay, and H new. So let's take some examples on the same. If we have something like HBr in presence of uh, peroxide R2O2 and H nu, this is called peroxide, then what would be the product form? Product form would be something like um, this would be the product form. But in this is the product form in anti-Markonikow rule. But in the Markonikow rule, you would have seen that the Br would have attacked this carbon atom. Oops. Br would have attacked this carbon atom because the carbocation would have formed on this carbon. So let us take a look at the mechanism of anti-Markonikow rule. So first step is we have the peroxide. So peroxide in presence of H nu, it gets converted into two free radicals. Now this free radical, one of the free radicals actually attacks on HBr and converts it into alcohol and Br free radical. So now what happens is this Br free radical, when it comes in contact with the alkene, so it will have it can have two intermediates. One can be, it can have free radical on this carbon, as this bond breaks up and creates free radical on here, this carbon and this carbon, or we can have free radical on this carbon. But as you know that this would be more stable free radical because of monomer of alpha hydrogens, hence this would be more stable product. Hence this actually so let me not write it as a fourth point, it happens then there itself in the third point only. So this free radical actually attacks on the reagent, the HBr which we are taking. So this HBr will now, though the free radical on the alkane will actually attack on the HBr to form CH2 Br. Okay, and obviously Br would be released as a free radical. Okay, so this completes our reaction mechanism of anti-Markonikow rule, and there's a few points that anti-Markonikow is a free radical addition reaction, and symmetric alkenes such as 2-butene will give same anti-Markonikow and Markonikow product because of its symmetry, as the name suggests. Okay, so some notes here are anti-Markonikow is a free radical addition reaction, and second point is symmetrical alkene such as butene will give same Markonikow and anti-Markonikow products. So with this we come to an end of this lecture. So till then, Good luck and goodbye.